This video gives a quick review of exponential growth and decay. Growth occurs when the base b of the exponential function is greater than 1, and the formula for exponential growth is f of x equals a times the quantity 1 plus r quantity to the x power, where a is the initial amount, r is the growth rate, and x is the number of time intervals. Decay occurs when the base b of the exponential function is less than 1, but also remember that our base for an exponential is always greater than 0, so we would actually have 0 is less than b less than 1. And up here for growth, it would be b is strictly greater than 1. The formula for exponential decay is f of x equals a times the quantity 1 minus r quantity to the x power, where a is the initial amount, r is the rate of decrease, and x is the number of time intervals. Let's do a couple practice problems. The first one says that a can of soda is placed inside a cooler. As the soda cools, its temperature C of t in degrees Celsius after t minutes is given by the following exponential function. C of t equals 19 times 0.89 to the t power. First thing is find the initial temperature. The initial temperature is going to be when t equals 0. And so we'll get C of 0 is 19 times 0.89 to the 0th power, and anything to the 0th power is 1. So this would just be 19 degrees Celsius. So that will be our initial temperature. Notice that was also just the number that was written in front. A is our initial temperature in the a times 1 minus r to the x power, or t power in this case. Does the function represent growth or decay? So we know that our b is 0.89. When we talk about b, we're talking about the base. And anytime b is between 0 and 1, that tells us that we're dealing with exponential decay, meaning that we'll have a decrease in the amount every time. By what percent does the temperature change each minute? So I know that that base, if I look at my exponential decay model, f of x equals a times 1 minus r to the x power. That's my general exponential decay formula. So that tells me that 1 minus r is 0.89. So to find r, I'm going to have to subtract 0.89 from 1. Or in other words, I'll get 1 minus 0.89 equals r. Add r to both sides, subtract 0.89 from both sides. So we're going to get 0.11 equals r, and then change that to a percentage. So we're going to have 11% decay. So in other words, our temperature decreases by 11% each time for each minute, because t is in minutes. All right, second example says to begin a bacteria study, a petri dish had 2,600 bacteria cells. So that was to begin. So this is the initial amount. So my initial amount is 2,600. Each hour since, the number of cells has increased by 15%. So increased tells me that I'm dealing with exponential growth. Let T be the number of hours since the start of the study. Make sure my units match up. I have hours here, so that's good. Let Y be the number of bacteria cells. Write an exponential function showing the relationship between Y and T. So I have exponential growth, so I'll have Y equals A times 1 plus R to the T power. And I just have to plug in my numbers. My initial amount was 2,600, so Y equals 2,600 times 1 plus 0.15, that's 15% as a decimal, to the T power. And so I'm going to go ahead and combine the 1 and the 0.15. So my final result will be Y equals 2,600 times 1.15 to the T power. I wasn't asked to solve, just set up the equation. So that's your quick review of exponential growth and decay. Remember, growth, you're adding the rate to 1, and with decay, you're subtracting the rate from 1.